Hello student, in today's session we start chapter number 5, Gravitation, and one of the article from Gravitation we have to start, and it is procedure to launch a satellite. Here we are talking about artificial satellite. As everyone know that Moon is a natural satellite of Earth. Moon is revolving around the Earth in a circular orbit, that everyone know. So you must have idea about the period of Moon around the Earth. Period of Moon means how much time Moon takes to complete one revolution around the Earth, and it is 27.3 days. Now here we are discussing about artificial satellites. So whenever I am talking about satellite, it is an artificial satellite after this article. Now how the satellite is launched, that we have to learn in this article. Now you remember one thing here. So you already seen in these several news, satellite is launched by a rocket. So when the news flash, India launched this satellite. That time one rocket you can see in a news which is going up. So basically you remember here, satellite is launched by rocket. Now here we have to learn basic steps to launch a satellite. So let I tell you. So initially, first satellite is placed on tip of multi-stage rocket. It is placed on tip of multi-stage rocket. Multi-stage rocket means the rocket which having more than one engine is called as multi-stage rocket. Now satellite is placed on tip of multi-stage rocket. Now here initially we are considering here, for simplicity we are considering two stage. So I am considering only two stage, means a rocket with two engines. Now second step. So I consider here this is Earth. So here it is a rocket. So this is first stage, this is second stage, and here it is satellite. And this is a rocket. So initially, first stage of the rocket is ignited. First stage of rocket is ignited, and by using this first stage, we attain desired height. As the first stage of rocket is ignited, and by using that satellite attain desired height. Okay? Then at that height, what happens? This satellite means at that height, satellite is turned with 90-degree angle. Satellite is turned with 90-degree angle, and the first stage of the rocket is detached. Now pay attention. We use first stage, we attain desired height. At that height, it is turned with 90-degree angle, and then first stage of the rocket is detached. So you can see that type of structure. This is a satellite and this is a rocket. Only second stage of the rocket is there at that height. Now second stage of the rocket is ignited. Now it is second stage of the rocket is activated, and by using that we give some horizontal velocity to the satellite. Second stage of the rocket is ignited, and by using that we give some horizontal velocity to the satellite, which is sufficient to revolve it around the Earth in a particular orbit. So this is a procedure to launch a satellite. And here you can remember here this horizontal velocity. I can consider this VH. VH decides the nature of orbit, or decide the possibility of orbit. It decides orbit. How the satellite rotates, it is decided by this horizontal velocity. I hope everyone understood the procedure to launch satellite. You remember here, this is simple procedure. It is launched by a multi-stage rocket, that is two-stage rocket. Then you have to write the use of two stage. First stage rocket is ignited, and by using that the satellite attains desired height. Now at that height it is turned with 90-degree angle, and the first stage is detached. Now second stage of the rocket is ignited, and by using that we give some horizontal velocity to the satellite. And this magnitude of the horizontal velocity decides the nature of possibility of the orbit. So this is the procedure to launch a satellite. Now here, let me decide the nature of possibility of the orbit. So after this procedure to launching a satellite, we decide the nature of possibility of orbit. So let me discuss different cases. So case 1. Now here, I am considering here where VH horizontal velocity. Then I can consider here VC for critical velocity. Now what is critical velocity? Let I tell you after some time. Then VE. So I will write it here. VE, escape velocity. Now we consider, so here horizontal velocity by VH, critical velocity by VC, and escape velocity by VE. Now the case number 1. So whatever the velocity, horizontal velocity given by the second stage rocket, if horizontal velocity less than the critical velocity. Critical velocity means the velocity due to which satellite revolve in a circular orbit. Critical velocity means the velocity due to which satellite revolve in circular orbit. That velocity is the critical velocity. And if horizontal velocity is less than critical velocity, then satellite follows elliptical path. Then satellite follows elliptical path with point of projection as apogee. Apogee means, so basically apogee means you can say a farthest point. Apogee means farthest point, means point at little larger distance. Let I show you in diagram. So you can see here, if this is Earth, let I show Earth, I will show here little smaller Earth. Now this is a point of projection. So this is the height h at which satellite is reached by first stage. Then here we are giving horizontal velocity. And if horizontal velocity is less than critical velocity, then satellite moves like this. So let I draw the orbit like this. So this is the farthest point and this is the closest point. So here point of projection as at apogee. Now case number 2. If this horizontal velocity equal to critical velocity, then the nature of orbit is circular. Then satellite revolve in a circular orbit around the Earth. Now case number 3. If horizontal velocity greater than critical, but here horizontal velocity less than escape velocity. Escape velocity means the velocity due to which satellite escape the gravitational field is the escape velocity. Escape velocity means the velocity due to which satellite escape the gravitational field is the escape velocity. Now here horizontal velocity we are giving, it is less than escape velocity. Obviously the satellite is not escaping the gravitational field 100%. It is not escaping. Now here I will show the elliptical path again, right, like this. This is the first case. Second case, circular path. So this is second case. Now here, if horizontal greater than this critical, but horizontal less than this escape, then it follows parabolic path. Sorry, here if horizontal greater than critical but horizontal less than escape, then it follow again elliptical path. Sorry, so here it follow elliptical path. This point of projection at perigee means at closest point, means like this. So So this is like this elliptical path. So this is the closest point. This point of projection is the closest point and this point is the farthest point. So here again, elliptical path, then point of projection at perigee. Okay, this is a third case. Now fourth case, case number 4. If horizontal greater than critical and greater than this escape. Horizontal greater than critical and greater than the escape. Then obviously it escaped gravitational field. Then it followed this type of path, tangential path, and escape gravitational field. So this is the fourth path. In that also, so here it followed tangential path and escape gravitational field. Escape gravitational field. One more case here we can write down. Case 5 also. If horizontal equal to this escape. If horizontal velocity equal to escape velocity, then it follow this type of path, means parabolic path. It follow parabolic path and escape the gravitational field. These are the nature of possibilities of the orbit that you remember. I hope everyone understood how to launch a satellite and the nature of possibility of different orbits here.